Thanks for the introduction, Rod and Kim. All right, I'm going to tell you sort of basically my journey as a mobile developer. I've been sort of through native, I've been through Xamarin, I've been through React Native, and sort of things that I've looked under the hood, things that have been good, bad, and just basically general experience. So here's kind of the agenda that I'm going to go through. My introduction, context, technical differences, performance differences, developer experience, debugging, pros and cons, DevOps, and then we'll do a Q&A at the end. All right, so who am I? My name is Michael Williams. I'm a TSP from Microsoft. I have about 8 years experience in mobile development. I've been sort of in the cloud for about 3 years on Azure, AWS, and Google Cloud. I've done a lot of work around architectural design in CQRS, and latest focus is around sort of TensorFlow machine learning. And a little interesting note about me, I went to North Korea last month. So, sorry for another conversation.
Did you didn't take any posters off the wall?
No, that's why I'm here. Okay, so first thing I'll start with is this line, building native apps is hard. I reckon that's complete nonsense. Building native apps is easy if you know how to do it. And if anyone starts off a slide deck with that, I would probably suggest walking out because it's usually a very high level overview of what cross-platform development is. So straight away, these are the drawbacks of cross-platform development. We have performance, and that's around parallel runtimes. We have application size because they always get inflated, except for React Native. It actually is quite lightweight. Complexity can be complex, especially if you're new to, say, Xamarin.Forms. I've been hearing in the community that people have been saying Xamarin.Forms is like the new WPF. And then correct implementation is probably the worst thing when it comes to Xamarin.Forms. If you see some of the apps that I've seen built in Xamarin.Forms, you would be horrified. All right, so let's get into sort of the differences in Xamarin versus React Native. Xamarin Approach, I'm sure we're all aware. It's model view, view model UI architecture. We can use Xamarin Traditional or Xamarin.Forms. And under the hood, it uses ahead-of-time compilation on iOS and just-in-time compilation on Android. Model view, view model pattern is quite easy to understand. The beauty about Xamarin is we have these options. I'm a huge fan of reactive UI. If anyone's ever looked at that framework, I highly suggest having a look at it. Jeff Huntley, I think his name is, he's now doing sort of dev sessions and coming to do speaking and talking about how to use it and how to build it into your Xamarin applications. So, Xamarin Traditional, if you're not aware of this, I know this is Xamarin Meetup, so I'm sure you are. That's Xamarin Traditional. We can get about 65% code sharing. We have the layers on the top, 3 different UIs, all written in C#. Xamarin.Forms. Xamarin.Forms shares the UI layer, and we can get up to, say, 95% code sharing, but we do have performance degradation because we're abstracting one UI layer. So let's go under the covers of what Xamarin.iOS is doing. So inside Xamarin.iOS, we have 2 parallel running execution environments. We have basically the mono execution environment that runs side by side with an Objective-C runtime environment. So when you compile a Xamarin application, the mono compiler, which is in the mono execution environment, that compiles your C# code into MSIL, Microsoft Intermediate Language. Then in Xamarin.iOS, ahead-of-time compilation requires that, so ahead-of-time compilation uses another compiler, takes that intermediate language and creates a native binary which can run on the ARM processor of an Apple device. So the security issue that Apple has given this concept is injecting managed code directly into the Objective-C environment and running it without having to do that pre-compiled stage. So that's why we have to do ahead-of-time compilation. That's compile it first, then run it on the processor. Now let's go to Xamarin.Android, and what's the difference there? Just-in-time compilation. So the way it works is it's exactly the same concept. We have 2 parallel execution environments. We have an Android runtime environment and a mono execution environment. We have what's called Android callable wrappers, which basically allows the managed code from your Xamarin mono execution environment to talk to your Android execution environment. And then we have managed callable wrappers, which do the other way. So that way you're getting communication between two execution environments. And those basically talk to each other through, they're made out of jar bindings. So that's what's happening under the cover with Xamarin.Android and Xamarin.iOS. So the difference between just-in-time compilation is you don't have to create that native binary first. We don't have to pre-compile the intermediate language. We can do that all at runtime straight into the Java execution environment. And that's just basically a general overview of sort of the difference. So here, this is just-in-time compilation. We have an interpreter which we chuck the managed code straight into the Java runtime environment. And up the top, that's AOT compilation, where we have to pre-compile that managed code, that managed code before running it on the iOS processor. Now let's talk about Xamarin.Forms. Under the hood of Xamarin.Forms, this is kind of just a really high-level look. We have a Xamarin.Forms UI element, and then we'll have sort of a render layer in between, and that will do the communication between a Xamarin.Forms element and a native UI element. Now talking about the actual layout cycle of Xamarin.Forms. So this guy, I think he's actually from Melbourne, Michael Vidland, did a really good post about sort of delving into the Xamarin.Forms layout architecture. It has two main passes. The first one is the invalidation layer, where basically all the invalidation bubbles from the ground up. So when you have a root, and then you'll have a parent, then you'll add a child, and then you'll add children into that child. And basically the invalidation will start at the very bottom and bubble all the way to the root of the UI tree. Then after this happens, we have the resolving layer or the measurement layer, which basically bubbles all the way down. So from the root of your UI stack, it will go down every single child and say layout and measure all the way to the bottom to the very last child. This is where, so you can see sort of Xamarin.Forms, how much is actually happening under the hood when you're just writing your XAML and your WPF code. Is you've got that parallel execution environment, then an abstracted UI layer which has to do these layout cycles. So there's a lot actually going on under the hood. But what's the beauty about Xamarin.Forms? I think what's coming very, very soon, and that's layout compression. It's going to really, really improve the performance and speed of Xamarin.Forms, those layout cycles. So that was announced at Build. I've chucked in a link on this PowerPoint deck, which I'll send out to everyone afterwards, and I suggest having a look at what's coming with Forms 3.0. It's looking really impressive. All right, this is all really good and all, but here are some of the disadvantages of Xamarin.Forms, which I have seen across different projects, and that's developers with no experience jumping straight into Xamarin.Forms. The end result is terrible. The 95% code sharing way of thinking is a trap because it's really, really cool. I got really hooked on Xamarin.Forms for a long time till I ran a project which hit a wall and I had to rewrite the entire UI layer because we just took it too far. And that's because I was focused so much on sharing code, the end result of what the user was using was a little slow. Scope creep is the biggest problem, I think, with forms. And that's with an app will start off like as a simple idea until suddenly you'll have maybe upper management saying we want to add feature after feature after feature. And that's when you get into this really bad performance bottleneck. So that's the biggest problem, I think, with Xamarin.Forms is scope creep. There's also the problem of incorrect implementation. I'll show you a XAML sheet that I got recently from a customer. They're going to require a lot of training after seeing it. But yeah, it's just basically a lot of the problems that do occur with Xamarin.Forms is around incorrectly implementing just simple MVVM structure and XAML code. It's actually quite a hard thing to get across to people sometimes. Can be confusing for developers as well. All right, now let's jump over to the React Native approach. So we have a Flux and Redux UI pattern. We have two approaches. We can actually do platform specific and we can do cross-platform. We have the exact same sort of approach as what ahead-of-time compilation and just-in-time compilation are doing. and that's a parallel execution environment where you're communicating JavaScript to the native layer. And then this runtime, the JavaScript runtime, it's known as JS Core, and we communicate between the native and the JS Core environment through a bridge. So the performance bottleneck in a React Native app is this thing here, and that's the bridge. So you want to keep this communication across that bridge to a minimal. So this is kind of like a really simple stack of what a React Native app looks like. So down the bottom in the dark blue, though, that's like the operating system. The JS runtime, which is known as JS Core, your React Native application will be injecting JavaScript into this layer here, and that will talk across to the native APIs of the operating system. And then on top, we have the node modules that come with the React Native application, and you can also include third-party components there as well. And the good thing sort of about this React Native stack is over here, which is the third-party libraries. So you can include native third-party libraries and be building your app in native and JavaScript. But you can imagine the complexity that comes with that. So Flux and Redux came from the concept of the virtual DOM. Does anyone understand sort of this? It's pretty straightforward. The concept of a DOM is basically, it's like a document object model. And what that is a structured document of how your UI is laid. Now the problem with a DOM model is every time we change one piece of that DOM, we have to re-render that entire tree again. And that's quite inefficient. But if we use the concept of a virtual DOM, we only need to render certain parts of the tree. So this is the approach of what React is doing. What Flux is doing. So this is the Flux pattern. This just comes straight off the Facebook website. It's all in the documentation. And the way it works is this. You have views on the right here. These are known as components. All you need to know is they simply do two things. They listen to a store and they fire off actions. When that action's fired off, that'll get passed across to the dispatcher. And what the dispatcher is just a pub sub object which receives every single action coming from different React components, and that will then push out those events into every single store of the Flux model. And then a store will only listen to certain events that are being emitted from the dispatcher, in turn causing the specific React component to re-render. So that's Flux in a really general overview. You can go into the documentation. If you ever do build React Native apps and want to understand what Flux is, I highly suggest looking more into this architecture because I think it's really good. Then we have Redux. Is anyone here familiar with CQRS at all? Cool, there's a few. So Redux actually is following a few similar principles from what CQRS was designed to do. So in Redux, we don't have multiple stores. We have one single store. So in Flux, stores are designed to store state, right? For a particular React component. Inside Redux, you have one store. One store will store the entire state of the application. A reducer is what they do. They will basically, a reducer takes the app state and also takes an action and then transforms that state into a new state. So a reducer contains what's called pure functions. All they're designed to do is update the state of your application based upon particular events. So there are three principles in Redux that it just follows, and they are exactly the same as what CQRS is as well. It's a single state for an application. State cannot be mutated. It has to stay. You can only transform state into a new state, and changes only ever occur to state through the use of reducers. So normally in Redux, it's actually a bit cleaner, I think, than Flux because you don't have multiple stores. State's just kept in one store. And reducers, you'll start off with just one reducer, and basically as your React application grows, you'll break that reducer into other reducers because based upon how you want to segment your UI tree. Now we're going a bit sort of deeper. So this is kind of how, like, what's happening under the hood with a React application. You have a JavaScript runtime environment, and you'll have your native code, and they talk to each other through the use of a bridge. They run in parallel, and your React Native application will sit inside that JavaScript runtime environment, where it will inject all its JavaScript code into. And that's kind of what it looks like if you have just a simple React Native component and how it maps to a native nav control and how they talk between each other. But see, like I was saying before, the performance bottleneck is the bridge. So you want to try to keep that communication down as minimal. And this is kind of what opens quite a nasty gate to sort of new developers of the framework, is because sometimes you're managing JavaScript and Swift at the same time, worrying about memory, how it communicates back and forth. It can be tricky. And the first time I was learning that concept, I struggled. It took me a long time to sort of understand it. Right, so put the same slide in twice. So this is when React Native gets really, really cool. It uses up to 4 parallel threads. So on top of your main thread, you'll have a JavaScript thread, a native modules thread, and a render thread. The main UI thread is what runs on the native iOS and Android platform. And this is what actually renders the native UI components, where you do the measuring, the laying out, how your screen lays out natively. You'll then have your JavaScript thread. That's what runs all the JavaScript code contained in your React Native application. You'll then have the native modules thread. This will sort of sit between the main thread and, this will sit between the bridge, the main thread. So all the code being executed from the JS thread is passed up in batches to the native modules thread, which will instantiate native components and do the communication between JavaScript and native code. And then the render thread, which is doing OpenGL commands on the UI, and that's done again only above Android 5.0, because OpenGL is used a lot to sort of render UIs past that version of Android. So this is kind of what the workflow looks like. From the JavaScript threads, usually where everything kicks off. This is after startup. Everything will start natively to startup. Once the JavaScript runtime is going, you'll run sort of everything from your JavaScript thread like so. So that's where you'll declare like a React component that JavaScript will execute. That'll be propagated and passed over the bridge onto the native modules thread, where that will do the accessing of like the native APIs, instantiate the native components, and then that will then be passed to the main UI thread on iOS and Android, which will do the actual render of the UI. Then once that rendering, measuring, and laying out of the UI is complete, it'll get propagated back down to the native thread, and then those events will be passed back over the bridge to your JavaScript thread. So that's how it's that two-way communication between JavaScript, native, and then back forward. This is kind of another look at sort of the concept as well. So that's the bridge. That's our React Native, that's our React modules thread, which runs this. That's our main UI thread, which runs entirely on natively. And then over the very right, that's where the JavaScript thread is run. So that's kind of how the communication works between all three. Last look. So this is what a healthy React Native app looks like. This is systrace, which I use to monitor sort of Android and get really sort of under the core of it. Systrace is really good, but it looks like a 1980s Windows application. So basically, this is a healthy React Native app. They're the 4 threads running in parallel. And you can see every single, this is purple, grey, color's not coming out too well. Every single chunk that moves along the screen, that's a frame. And you ideally want to have no processing cutting over a frame. As soon as you do that, that's when you'll start seeing the UI perform quite sluggish. So you can see there, it's passed equally between all 4 threads, so you know, hey, it's looking good. You're reaching max performance there on a React Native app. This is an unhealthy React Native application. So see how we got at the bottom, that's where you're seeing that work being passed across those frames. That's when you'll start seeing sluggish UI and performance will be slow. All right, enough of React Native. So major disadvantage of React Native is coding in 2 languages, Swift JavaScript and Java and JavaScript. Native embedding for developers is quite tricky. I've found it quite hard to learn, but I mean, once you understand the concept, it's applying the same rules. JavaScript is unsafe, technically defective, and slowly evolving. I have a really good blog post of someone who did a really in-depth research of sort of where JavaScript's going, where React Native's going, and I think it's really worth reading if you want to sort of look at adopting React Native as a permanent long-term approach. All right. Okay. So just to summarize, both frameworks, they all support iOS, Android, UWP. React Native's implementation is new. They both produce truly native applications. They can achieve 95% code reuse. They're all high performant as long as you apply them correctly. They both compile into native code, ability to access third-party components, and they both do native embedding. React Native's approach is actually much faster than what Xamarin can do. Xamarin.Forms can do with custom renderers because you're staying actually purely in native. All right, performance. I think this is an important topic. So Xamarin Performance, ahead-of-time compilation, just-in-time compilation. 2 parallel runtimes, the performance is excellent. There is only a very slight, tiny little bit of performance degradation when you go really deep, but the user will not even notice. So this was an article that was written, it was last year. It's improved Xamarin.Forms, but these load times and performance times, scrolling times, to me is unacceptable. I've just seen so many issues when it comes to the end result of some Xamarin.Forms apps. When you go heavy on the UI, that's the sort of performance loss that you're losing on a Xamarin.Forms UI. And I think this is important to see. I know Xamarin.Forms is cool technology. Look, it's brilliant. You can build apps which are super performant. But some of the measures that I've seen on some Xamarin.Forms apps, the overhead is just a little too pain. It's a little bad. React Native performance, I'll send you this afterwards so you can have a look at these links personally, but the React Native performance is actually quite impressive. It's very lightweight. Memory is actually fantastic, and the performance of it is fantastic. But to get this performance requires a huge amount of understanding of native and of React, of Flux. You need very experienced developers to come up with those results. ListViews and React Native. So here's some examples of like some people that hit walls, incorrect implementation. These are just some examples I was going through on the web, which some problems people are having. List view initial rendering is too slow, or scroll performance is bad for large lists. When I first implemented a list view, I was like, I'm never touching React Native again. Simple solution, use a flat list or section list. All that took for me to figure out that solution was go read the documentation. And this is what some people are not doing with Forms and with React Native. Just read the documentation. Xamarin.Forms, custom view cells in Android. Yikes. Use caching strategies, retain, recycle elements. It can fix the problem, depending on how sort of custom your view cell is. If it's really custom and you're putting a lot of elements in, yeah, we're not going to talk about that. And then Xamarin Traditional, it's native. There's no problem. React Native navigation is horrible. There is no standard. It's all open source and it's all done differently. It is horrible. It's confusing as well. Page transition is slow. So this was a funny blog post where someone wrote this. How they fix slow navigation. We started scheduling the animation using the interaction manager. While making the transition, we loaded less content, render the remaining content once the transition is complete. It helped us provide a smoother experience to our users. Now look at that workaround to try to get fast navigation. Xamarin.Forms, navigation is awesome. It's easy to understand. It's simple. It's straightforward. We can control it through our view models. It's awesome. There is nothing wrong. Anyone that says to me, please use Prism, please don't. I've worked with 3 projects that I've had to take it out every single time. 1, it doesn't do page caching. And 2, your navigation stack always becomes quite customized. Prism is very limited. I've worked with 3 apps where every single time I've put it in, 2 weeks later I've had to take it out. Cons, bindings are delayed in transition. So I don't know if anyone's ever written a Forms app, changed a page, and you'll see data appear, then change because of bindings are delayed. That it can be quite an issue sometimes. Piece of cake for Xamarin Traditional, no problems there. UI animation. React animation APIs all run on JS thread causing performance issues. But I will say that it's constantly improving. From a year ago to what it's doing now, it's almost not an issue. Xamarin.Forms is pretty good as well, as long as you don't do too much. And Xamarin Traditional is as good as native. So just a quick summary there in performance. Xamarin Traditional, Xamarin.Forms, and React all run great on iOS. The problem is Android. All right, memory management. Memory management in Xamarin. Look, it's really, really good. It uses the .NET GC garbage collector. Basically what that means is it periodically stops, freezes the stuff you're not using, and continues running the application. This is just a .NET garbage collection approach that's been used for a long time. Except this is where it gets complicated. Between the binding layer, you have objects that live both in memory in both runtimes. And that's where memory management can get a little messy. But as long as you're applying correct C# like disposing and memory management handling techniques, it's not a problem. Although in Xamarin.Forms, I recently was working on a project with some colleagues of mine in the States. Xamarin.Forms is still having problems with freeing memory on image allocation. I mean, it's been a long time and they still haven't gotten it right. So this is what I mean by memory management handling techniques. Implementing iDisposables for custom classes, embedding them in using statements, and use weak reference for class level properties. This is specified in the documentation for people building Xamarin applications. And event handlers as well. As long as you're adding and removing them correctly, memory is not an issue. When I first built my first ever Xamarin application, I never actually freed any event handler. And when I left that contract, I had a friend at work call me and say, mate, did you ever profile this app? And I said, no, why? And he goes, check out this screenshot. And the memory was up into the sky. It was quite embarrassing. Just with this stuff, you've got to read the documentation, know the best practices, and be sure that you're implementing best practice. So actually, unfortunately for React Native, I haven't been able to look under the cover with it. But I've profiled it and I've seen the memory being handled correctly. As far as I'm aware, React Native completely does, or memory management is done completely native. I mean, I don't think there is anything going on in the JavaScript level, but I can't be sure. I haven't been able to find any documentation on it yet. So this is basically image handling. Facebook's Fresco image library is what's used under the hood for React Native. It's important to understand how to configure that library before you start doing React Native, because if you don't know how to configure Fresco, you'll have a huge amount of memory issues with React Native on Android. Xamarin.Forms, Android is terrible. I'm still seeing bindings and memory issues. Xamarin Traditional is good as native. You'll be getting this afterwards, so you can have a read. These are just some best practice approach for image handling with React Native. It's mainly around Fresco, and I highly suggest looking at it. Okay, debugging and profiling. Debugging in React Native. Look, both frameworks are very, very good. I think the only thing with React Native is it's not as integrated as nicely as what Xamarin is. Nowhere near, actually. If you want to do remote JavaScript debugging, you can do it through Chrome, which is quite messy. systrace on Android is actually very good. It's an old tool, but it's very good. Hot reloading is absolutely awesome, especially if you just have to run the app once and just press Command R every time you're making JavaScript changes. So this is where it's actually really good hot reloading. When you release an app, and if it's React Native, you can push JavaScript changes without having to push the app again. Really useful. And then you can use Android Device Monitor and Memory Analyzer. See, these tools, but these are the same. You can do this in Xamarin as well, systrace in Xamarin as well. But yeah, these are the tools we sort of have to use for React Native. This is sort of what it looks like for profiling in React Native. We can use iOS instruments and Android Device Manager or systrace. We can do this in Xamarin as well. So this is where React Native is far behind what Xamarin can do. Xamarin has all these tools integrated, and these tools have been growing for the last few years. Inspector is really cool. You can actually, whilst you're running or building your UI in a Xamarin app, if you run Inspector, what it'll do is it'll run an application where you can jump in and see your screen and all the layers in 3D and make live UI updates, but it's really useful. You can build your UI quite quickly. Previewer hasn't worked since they announced it in Evolve about 3 years ago. So I've been frustrated with that for a long time, but I'm telling you just now, it is working. So I was with this recent Xamarin.Forms app that I was building with my colleagues. All of us were blown away by the fact that we could use the previewer because it was working. Profiling in Xamarin is awesome. It's got its own the Xamarin Profiler, and now this is all embedded inside sort of Visual Studio, both Mac and Windows. And so again, profiling. Yeah, the previewer versus hot reloading. I think React Native wins here. I think it's much faster, and the previewer still has issues after being in development for close to 3 years. Then we have deployment. Who wins? React Native wins here because you can push instantaneous updates through JavaScript. So here's a real rough, high-level overview of like pros and cons. Xamarin, Microsoft supported. That's a thing for anyone building for an enterprise app you should be very aware of. And that's if you have issues with a Xamarin app, you have Microsoft there to help. Release cycles are stable. Really, I will say that. On Forms, sometimes I still see issues. Development environment it's unbeatable. They have the best development experience for building an app by far. C# is the language, and it's evolving massively. React Native. Facebook wrote it. So I was reading a funny thing about Facebook. So Facebook gets 1.8 billion users logging in per day. They have to run close to 200,000 servers to manage that workload. That's $1 billion in infrastructure alone to manage that workload. So do you trust Facebook to run a performant mobile app based upon that weight load on their website? I think it's a pretty good indicator. Package sizes are lightweight, it's multi-threaded, and the release cycle's every 2 weeks. But if you've ever tried to update React Native, it's horrible. It breaks all the time. The node modules, I mean, but to be honest, Xamarin.Forms had the same issue every time you updated. It would break the app. The ugly. Inflated app package. Don't ever look up at the size of a Xamarin.Forms APK or IPA. It'll scare you. I've put the same thing twice. Oops. And then do I choose Xamarin Traditional or Xamarin.Forms? That's the biggest problem with Xamarin, is which road do I go down? People are still making that mistake. React Native. The language is JavaScript. There's many reasons there. It's not evolving language. yeah, like I was saying, it's technically defective. By that, I'll give you basically the reasons why you should read about that. Licensing concerns. That's the biggest problem with React Native today, is the license and the patent that they have on their website. The development environment is not that great, but if you're a web developer, honestly, you'll find it very good. You'll find it easy to use, put it that way. And you still have to work, I know it's cross-platform, but you still have to work in Swift and JavaScript and Java and JavaScript. You've got two languages there. Especially in Swift and JavaScript, they're completely different. So this is the main concerns of React Native, is the top one. If you file a patent claim against, or a patent claim that involves a product or service of Facebook or an affiliate, or a patent claim that involves the React software, they have the right to basically take away your React license and you can no longer use it. That's the biggest concern anyone in an enterprise company should be aware of. Because if you do something to piss Facebook off and you've got like 7 apps in the store, they could just literally take your React Native license away and those 7 apps are gone. And the uncertain roadmap is a concern. It doesn't have the enterprise support that Xamarin does, nowhere near. So if you have problems with React Native, you're on your own. You have a problem with Xamarin, you've got Microsoft behind you. So the uncertain roadmap is scary because like they've got Facebook, right? They don't need to make any more money. If they can choose at any point to just stop supporting React Native, and no one knows where it's heading. So that's again the risk with it. The long-term risk with it, that's still there. So developer experience. This is sort of what you're looking like with the Xamarin app. I ignore the Azure part in the middle. You can add AWS in if you want. Xamarin University for learning. I mean, the Xamarin University content is incredible. You can teach people that have never built mobile apps to being a full-scale mobile developer through that program. You can build it in Visual Studio. Visual Studio is an IDE that's been around for years. You can integrate it very nicely with Azure. All the NuGet packages are all done for you for things like data sync and all that sort of stuff. You have Test Cloud, you have Hockey App, you also now have Mobile Center. All this stuff is completely integrated. That's where Microsoft, to me, still is ahead, is the integration aspect of all these tools. So this is where React Native is. These 3 areas are the parts that are missing. DevOps. This is your mobile app lifecycle. We've all seen this. Build, test, distribute. How do we automate all that? This was and still is kind of the DevOps approach with Xamarin. Code repository on VSTS. If you're using GitHub, most people are probably using GitHub. This is kind of what DevOps looks like with a Xamarin application. Sort of the best approach, I would say, because you get build deploy through VSTS, and you also get app testing through Test Cloud, which plugs directly into VSTS through a plugin. Setting up a build definition to do build, test, deploy is very quick, and it's very easy to do. Then you can also plug it into Hockey App, get all the crash analytics and telemetry, and you can pump that basically back into VSTS. It's all integrated. See, the Microsoft approach right now with this integration is super powerful. So this is kind of a setup for like a React Native approach. You can actually do it in VSTS. I've done it before, but it's all through custom scripts. This is just this blog post here. I would suggest having a reading. He set up just like an ecosystem around sort of a React Native app. Jenkins, and then you've got sort of code push. Fastlane is an open source command line tool for React Native for DevOps. It does things like code provisioning, app provisioning, key store provisioning, and automated building. And then he's plugged it into Crash Analytics, which talks to iTunes Connect, and you can also use that for beta testing. So that's kind of like that's a very open source DevOps approach. That's what React Native is at the moment. But what's coming out by Microsoft is this one, and that's Visual Studio Mobile Center. So this is available, it's going GA in November. We don't know about pricing yet, but basically it is a super powerful tool that you can plug in source code, whether it's a native iOS, native Android app, native UWP app, whether it's a React Native app, or whether it's a Xamarin app. You can plug the source code directly into this portal and get build, test, deploy just by the source code. All right, so the most important question is, which framework do you choose? I would suggest all you have to do is ask yourself this. Are you web or are you .NET? Both of them are very, very good. Why would you try to teach a bunch of web developers .NET tools when they already know how to build .NET? Build in React or build in JavaScript. It's sort of, I've worked on some teams building React where we tried to bring in Xamarin, and it didn't work because it required them sort of jumping into different tooling, different programming patterns. MVVM, some of them hadn't done before. It took a lot of training to bring them up to speed. Then we tried bringing in React Native, and they jumped on that much quicker, and we published the app much faster. So normally I would say that's the question you should ask and see what your resources are on a development team to start with. But here is sort of the main areas which we just covered where I think who wins in each area. Complexity, I think Xamarin Traditional wins there. Performance, Xamarin Traditional and React Native, but it requires experienced developers to get that React Native performance. Memory management, I think Xamarin Traditional and React Native are equal on that part. Developer experience, Xamarin wins by far on tooling integration. Debugging, Xamarin. App Store deployment, React Native, because you get code push and instantaneous JavaScript deployment. DevOps, Xamarin wins on integration. So who wins today in the market? I reckon is Xamarin Traditional. Personally, from my experience in all three, it's performant, it's risk-free, it manages memory, it's an evolving language, C#, it debugs, developer experience is awesome, DevOps is awesome. It's the most risk-free, fastest way, I think, to build an app. And if you start integrating this with like MVVM Cross or Reactive UI especially, it's super powerful. To me, that is the safest way. But I like C#, I like JavaScript. Personally, if I build a Xamarin application for a customer, I'll stay there. I won't go Forms unless I'm doing my own projects. I think it's just performance bottlenecks for me. Is just from my experience. People will tell, I'm sure, will say otherwise. But I reckon today, as a risk-free sort of framework, that's sort of the approach that I take. What makes a good cross-platform developer? A developer who understands native development. I've seen so many people hand me resumes with saying that they've done native development, and I ask them 3 questions about a UI view controller, and they have no idea what I'm talking about. Native development is quite important with cross-platform frameworks because performance, memory, you need to understand what's going on under the hood. You need to understand what's happening with the UI, ahead of time compilation, just-in-time compilation, JS core, understand Flux, understand MVVM. You need to read the documentation. And that's a problem that I've seen with mobile developers is they build an app, they think that's the be-all and end-all. Underneath the hood, they're missing so much what's going on. And again, correct implementation, and that's, reading the documentation. The memory management approaches that I showed you there in Xamarin about using iDisposables and wrapping them in using classes. Apply those approaches. You have to do it. And I'll end there. There's some useful links for some sort of more reading, and I'll send these out at the end. And that's pretty much it. Thanks, everyone.